Okay, this is example 2 on the non-constant acceleration worksheet. So for this one, we have the velocity of a particle given by v. And I'm going to work in column vectors this time, which you may prefer. So 2 minus 6 t squared meters per second. T is greater than or equal to 0. T is the time. The particle has displacement of 7. No, sorry, it's not 7. I changed it. It's 1 minus 18 when t equals 2. So we've got some initial conditions here. And we want to find an expression for the displacement of the particle at a time t. So to get from velocity to displacement, we need to integrate. So displacement is the integral of the velocity with respect to time. And so we're looking at integrating a vector. So usual rules of integrating, you just need to do the x and y components separately. So 2 integrates to 2t, but we mustn't forget the constant of integration. So that is going to 2t plus c. And minus 6t squared, if I add 1 to the power divided by the new power, I get minus 2t cubed. This will also have a constant of integration, but it's not the same constant of integration as this one, so we need to give it a different letter. So plus d, or a letter of your choice. So integral of s, and then we have these boundary conditions we can use in order to find c and d. So using this, 1 minus 18 is equal to, so we're letting t equal 2. So I get 4 plus c. And if t equals 2 in here, minus 2 cubed is 8 times minus 2 is minus 16 plus d. And so equating x's and y's, 4 plus c has to equal 1, and so c is equal to negative 3. And minus 16 plus d is equal to negative 18, and so d is negative 2. And so an expression for the displacement at time t will be 2t minus 3 and minus 2t cubed minus 2, like so. Second part, at what time does the particle cut the y-axis? So usual rules here really, in that if it's cutting the y-axis, then the x component will equal 0. And if the x component is 0, 2t minus 3 equals 0. And so t is equal to 3 over 2. Job done.